Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n cubed plus n is equals to 2, and we will solve this problem for the real values of n. So here the condition is that we can solve this problem for the real values of n. So the very first thing we are going to do is, here first I can rewrite this equation as here we move this 2 in the left hand side, and you get n cubed plus n minus 2 is equals to 0. And after that I can rewrite this equation as n cubed plus n. Here you have minus 2, we write it as minus 1 and whole is equals to 0. And now I can make the pairs of cubic term and the other term. So here I can make the pair of n cube with minus 1 and plus we make the pair of n with minus 1, and this whole is equals to 0. And after this step I can apply here the nice cubic formula, and you know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b square. So now I can apply this cubic formula on the first term, and here I can write this one as 1 cubed, so that now we can apply this cubic formula on the first term, and you will get here n minus 1 times of n squared plus n and plus 1 square, and this whole is equals to 0. So here we have plus n minus 1 is equal to 0. So here we have plus n minus 1 and whole is equals to 0. And now you can focus on both of the terms, and you see that here we have n minus 1 be the common term, so that we will take common n minus 1 here, and you get n squared plus n plus 1 square will be equals to 1, and here we take common n minus 1, and here you get only plus 1, and this whole equation is equals to 0. So that here we have two cases. The first case is we take n minus 1 is equal to 0, and the other case is we take n square plus n plus 2 is equals to 0. So in the first case you will get the value of n is equals to 1. So this is the first root of this equation. So in order to find the other roots, we can solve this quadratic equation. So because in this question we need only real roots, so that here I can first check is this quadratic equation has real roots or not by using the discriminant formula, so that here I can check it. So here we have a is equals to 1, b is equals to 1, and c is equals to 2, and our discriminant formula is delta is equals to b squared minus 4 times of ac. And now I can first explain little bit about this discriminant formula. You know that if the value of this delta is less than 0, then we can say that this quadratic equation has no real roots, and if the value of delta is greater than 0, then we can say that this quadratic equation has two real roots. And if this delta is equals to 0, then we can say that quadratic equation has one real root. And now we can check the behavior of this delta by putting the values of a, b and c in this formula, and here you obtain delta is equals to b square, and the value of b is 1 square minus 4 times of a is 1, and c is equals to 2. So here you have 1 square is equals to 1 minus 4, 2 is 8, and 1 minus 8 is equals to minus 7. And here you see that our delta is less than 0, and here I can write, if the value of the delta is less than 0, then we can say that this quadratic equation has no real roots. So here this delta is less than 0, then we can simply say that it has no real root, so that we will rejected this case and we can just proceed here this case only. So finally we can say that n is equals to 1 be the only solution of the given equation. So now we can check, is this solution satisfies the given question or not. So that here I can put n is equal to 1 in the given question. So our given question is n cubed plus n is equals to 2, and now I can put here n is equals to 1. So you get here 1 cubed plus 1 is equals to 2, and 1 cubed equal to 1 plus 1 is equals to 2, and here finally you say that 2 is equals to 2. So this shows that n is equals to 1 satisfies given question statement. So here we say that n is equals to 1 be the only solution of the given question, and this is the our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.